All right, today what we're going to be doing is starting our new unit of quadratics. So we're going to learn about solving quadratic equations. So let's get started. A quadratic equation is in the format y equals ax squared plus bx plus c. Quadratics will always have an x squared term, so that exponent of 2 makes it a quadratic. So here's some examples where you have ax squared plus bx plus c, ax squared plus bx, ax squared plus c, or just ax squared. A can never be 0 because then it would be linear. So let's get started with the first part of how to set up a quadratic equal to 0. So all you got to do for the first part is just wherever you see f of x or y, you're just going to change that into 0. And that's the very first step when we're learning how to solve it. So again, wherever you see f of x, or if it says y, you're just going to change that to 0. All right, so here, all you would take is wherever this y is and just make it 0, and then bring everything else down here. Now, sometimes if it's not already set up like how it is up here, you've got to make it equal to 0. So the goal is we want to move everything across the equal sign to the other side. So in order to do that, we have to first subtract 5x. I like to move the variables. That cancels out, and you're left with -2. And then now we've got -3x squared minus 5x. Now remember, the exponent here is 1, so these are not like terms. But now we still have to get it set equal to 0, so we have to move this over to that side. So we need to add 2 to both sides. And then once we do that, again, none of these are like terms, so we just write it all out like that. And then that cancels out to give you 0, and now your equation's set equal to 0. So again, I want you to try this one on your own, but you're going to move this over by subtracting 2x. You're going to move this over by subtracting 4, and then combine any like terms to get it equal to 0. All right, some vocab for you. Solutions are also known as x-intercepts, zeros, and roots. Now, for solutions algebraically, the solution is any kind of number that makes an equation true. So what we do is first we need to figure out, is x equals 4 a solution? So you're going to take wherever you see x, and we're substituting in 4. So x is right here, and remember, whenever you substitute in values, put it in parentheses. So 4 squared, which is 16, minus 20 equals 5. Well, -4 does not equal 5. So this is a false statement, so that means 4 cannot be a solution. All right, now be careful when you have negatives here, because if you were to do it this way, remember, it's still in parentheses. And then go ahead, and I want you to try that one, and if you did it correctly, the answer should be yes. So show the work to prove it. All right, so now we're going to do the same thing. We're going to take this equation, and it's x equals 7 a solution. So same thing, wherever you see x, we're substituting in 7. And if you get a true statement, so 7 squared is 49, -5 times 7 is -35, and then bring down the -14. So now go ahead and combine all this. That's going to give you 0. Bring down this 0. Since 0 does equal 0, it is true, so yes, this is a solution. So okay, go ahead and try this one, and if you do it correctly, it is a solution, but make sure you show the work to back it up. And then now we're going to go through and we're going to actually solve the equations. So when we're solving, you want to set it equal to 0. That's always going to be your first step. Then find the GCF and make sure the first term is positive, very important. We're going to factor and then set each of the factors equal to 0 and solve. So the zero product property says if A times B equals 0, either A is 0, B is 0, or they're both 0. So let's get started with this first one. What we're going to do, it's already set equal to 0, so we're good there. We don't have to worry about any GCFs because it's already in factored form. So we're going to take this and equal it to 0. Then we're going to take this factor and equal it to 0, and then just solve for x. And then do the same thing here. So these are two separate. And then x equals -4. And these are called the solutions. Now, if you wanted to find the original equation, all you have to do is take your factored form and do your FOIL, do your distributing, whatever you call it. I just say distribute. So then you would take x squared, x times 4. Then remember it's -2 times x, and then -2 times 4, and then combine your like terms, and then this would be the original equation. So your solutions are here, and your original equation is here. I want you to go ahead and I want you to try number 2, and I'm going to give you a hint. You're going to, if you do this correctly, your answer should be -6 and 8, but again, show the work to back it up. And then your original equation, you should have x squared, oops, don't forget to equal y. There you go. Alrighty, so all we did was just set this equal to 0, take this, equal it to 0, and then go ahead solve. And then for the original equation, just distribute. So you got -8x plus 6x minus 48. So these are your answers. Well, let's go ahead, let's try this one. All right, so now we're going to take each part. So we're taking this 3x, setting it equal to 0, and divide both sides by 3. So x equals 0. Then we're going to take this part that's factored, and we're setting all of that equal to 0. And now we have to add 1 to both sides. And remember, we're dividing both sides by 2, and x is 1/2. So these, oops, I forgot to box those. These are the solutions. And then to get your original equation, you just distribute. So this was the original. All right, so now what we're going to do is we're doing all the steps that we've done before with factoring. So we're first going to, does it have a GCF? Oops, sorry. First we're going to set it equal to 0, my bad. All right, so set this equal to 0 by moving this over here. So we're going to add 17x. Now we've got all of this, so now we're going to look for a GCF. There is no GCF, so we can just keep going. So we're going to do A times C, so 2 times 21 equals 42, and then B is positive 17. So we need to figure out what would equal 17, but multiply to give us positive 42. And it would be 3x and 14x. So we're bringing those, and then just bring these, the first and the last term down. Make sure it's set equal to 0. And then remember, within here, we're going to factor out the GCF, which is x, and whatever is left over goes inside the parenthesis. And then for this part, we're going to factor out the GCF, which is 7, and then whatever is left over goes inside the parentheses. So now, these two make one set of parentheses, or one factor. These two make the other set of parentheses, and remember, these should be the same. And then we're setting each part equal to 0. So we're taking this, equal it to 0, and solve. and x equals negative 7. Then we're taking this, setting it equal to 0, and solve by subtracting 3, and then divide by 2. And we have x equals negative 7 and x equals 3/2. So it's just extra steps from what you've done before, because now we're setting it equal to 0 and solving. So same thing here. We're first going to set it equal to 0. And then once we move this over to the same side, or I guess actually this, since this is negative, I want to move it over here, sorry. So I'm going to go plus 4x to the third. And then since we moved this over here, the 0 is going to be here. So now I have a positive 4x to the third minus 100x. Now we're going to look for GCF. And yes, there is a GCF of 4x. So we divided each term by 4x. GCF goes out here. Everything else left over goes inside of here. So now, if you look here, this is actually a difference of squares. So remember, with the difference of squares, you're going to change one to a plus, the other to the minus, and then take the square root of both. And then don't forget to bring your GCF down. So now I've got 3 different things to set equal to 0. So I'm going to take the first one, 4x equals 0, and divide both sides by 4, and you get x equals 0. Then I'm going to take x plus 5 equals 0, or subtract x from both sides, and you'll get x equals negative 5. And then I'm taking x minus 5 equals 0, and then add 5 to both sides, and you get x equals 5. So there are actually 3 solutions, which again makes sense because at the beginning we have x to the third. All right, I want you to go ahead and try this one. And if you do this one correctly, your answer should be 0 and 2. So again, you have lots of work to show, so make sure you show those. All right, and then this is just more of practicing. So I am going to have this pulled up here. So again, we're going to move everything over to this side to set it equal to 0. And then for this part, there's no GCF, so we're just going to go ahead and we're going to factor. So a times c is negative 15, and then b is negative 2. So then that will give you negative 5 and positive 3x. Go ahead, break it down, do the GCF right here, and whatever's left over goes inside. Then we're going to take this section for the grouping. GCF is 3, and then left over is x minus 5. Now, whatever is outside the parentheses makes one group. Whatever is inside the parentheses makes another group. Set those each equal to 0, and you'll get negative 3 and 5. And on this one, again, we're going to have a difference of squares because there's no GCF, but 9 is a perfect square. Even exponents are perfect squares. 25 is a perfect square, and it's got a minus sign in the middle. So what we do is we take this, we make 3x, we take this, the square root, which is 5, and then since it's the difference of squares, we make one sign plus, the other negative or minus, and equal it to 0. So set this equal to 0, and you'll get x equals 5/3, or negative 5/3, excuse me, and then set this equal to 0. Solve for x, and you'll get x equals positive 5/3. Go ahead, and I want you to try those two, and if you do this right, I will tell you there is one, oops, where'd it go? All right, so you should have x equals negative 6 and negative 3 as your answer, and then if you did this one correctly, you should have negative 3 and 3 as your answer. All right, and then finally, this is the square root property. So this one is just saying, this is just a different way to solve it. If ax squared equals c, you can solve by taking the square root of both sides. So since we are introducing the square root, we will need to take the positive and negative answer. So one way to do it, difference of squares. So this, we can just break it up and then do a plus and a minus and solve. So that's one way we practice. This is the new way or a different way. Or what we can do is, since this is a perfect square, that's a perfect square, we can actually add 16 to both sides. Now you're going to get x squared equals 16. Well, the inverse of a square is a square root. So you can take the square root of both sides. But when you do that, you're going to get positive 4. And you're going to get x equals negative 4. So this symbol right here, you say it as plus or minus. So example, so this means positive 4 and it means negative 4. So this is another way to solve it. You could also do this way, so whichever way works for you. So here's another example. So in this case, I'm going to add 27 to both sides. 3x squared equals 27. Divide both sides by 3. So now I'm going to get x squared equals 9. So we're going to take the square root of both sides. And then when you introduce the square root, it can be plus or minus 3. So your solutions are this. Or we could have done GCF. And we'd still get x equals 3 and negative 3. So either way works. Oops, I forgot to equal it to 0. So you'd still get the same answers even if we did the factor way or if we did the square root way. So go ahead, I want you to try this one. And this one you will get a fraction. So you should get plus or minus 7/3. And then that is solving equations, or solving quadratic equations.